You've been lied to, not maliciously, not with intent to deceive, but fundamentally, systematically, across every documentary, textbook, and late-night conversation you've ever had about where everything came from. We've spent centuries obsessed with the wrong question. We ask, what created the universe? Was it a Big Bang? A quantum fluctuation? God's hand moving across the void? But while we've been staring at that question, arguing over cosmic origin stories like rival prophets, we've missed something far more disturbing, far more impossible to explain. The universe had a beginning. Fine. Everything points to that moment 13.8 billion years ago when space, time, matter, and energy erupted from nothing. But here's what should keep you awake at night. Why does the universe obey rules at all? Think about that for a moment. Truly think about it. Right now, in this exact instant, every atom in your body, every photon streaming from distant stars, every electron spinning in the silicon of your device, they're all following the same laws. Not similar laws, not approximately the same laws. Exactly, perfectly, identically the same laws. Gravity pulls at the same strength in the Andromeda galaxy as it does in your living room. Electromagnetism binds atoms together with the same fundamental charge, whether those atoms are in your brain or in a rock orbiting a black hole 50,000 light-years away. The speed of light doesn't vary. The mass of an electron doesn't drift. The curvature of space-time obeys Einstein's equations without exception, without variation, without a single documented case of rebellion. In the entire observable universe, there are 10 to the 80th power atoms in the observable universe. That's a 1 followed by 80 zeros. Write it out on paper, and you'll run out of page before you run out of zeros. Every single one of those atoms, every last one, plays by the rules. Not most of them. Not usually. Not on average. Every single one. No exceptions. Ever. In the 14 billion years since the Big Bang, across billions of galaxies, across distances so vast that light from some stars will never reach us, no matter how long we wait, there has never been a single confirmed instance of an electron saying, "Not today," to the electromagnetic force. Never once has gravity taken a lunch break. Never once has thermodynamics decided to reverse itself just to see what happens. Why? We take this for granted because we've lived with it our entire lives. The sun rises because of laws. Your heart beats because of laws. You're reading these words because electrochemical laws in your neurons are firing in precise, predictable patterns. But strip away the familiarity and what you're left with is utterly bizarre. These laws aren't objects. They're not things you can point to, touch, weigh, or photograph. They have no mass. They have no location. They don't exist somewhere in space. You can't collect a jar of gravity or bottle electromagnetism or trap the conservation of energy in a box. Physical laws are invisible, intangible, and completely undetectable, except through their effects. They're ghosts that control everything. And yet they're more real than matter itself. Atoms come and go. Stars are born and die. Black holes evaporate. But the laws? The laws are eternal, unchanging, perfect. They existed before the first atom formed, and they'll exist after the last star burns out. They need nothing to sustain them. They require no maintenance, no energy input, No cosmic administrator checking that gravity is still set to 9.8 meters per second squared on Earth. They simply are, and everything obeys them without question, without deviation, without the slightest possibility of rebellion. Now here's where it gets truly strange. We can describe these laws with mathematics. We can write them down as equations. We can predict with stunning accuracy what will happen when forces interact, when particles collide, when stars collapse. Einstein's field equations can tell you exactly how space-time curves around a black hole. Schrödinger's equation can predict the behavior of quantum particles with precision so absurd it makes your head spin. We've gotten very, very good at describing what the laws do, but we have absolutely no idea why they exist in the first place. Think of it this way. Imagine a chess game where every piece moves exactly as the rules dictate. The knight always moves in an L shape. The bishop always moves diagonally. Pawns march forward one square at a time. Never sideways, never backward. Now imagine there's no rule book. No one wrote down the rules. No player enforces them. No referee watches the board. Yet every piece, in every game, throughout all of history, has always moved exactly according to the same patterns. The knight has never once moved like a rook. Not even by accident. Not even when no one was watching. The pieces simply know what to do, and they do it. Perfectly. Forever. That's our universe. The chessboard is real. The pieces are real. But the rules are somehow more fundamental than the board itself. And nobody knows where they came from. This is the enforcement paradox, and it's the most overlooked mystery in all of physics. We have no cosmic police force ensuring that electrons obey the laws of electromagnetism. There's no universal court system issuing citations when particles try to break the speed of light. No rulebook floats in space that atoms consult before deciding how to behave. The enforcement is perfect, absolute, and completely unexplained. It's as if the universe contains within itself an invisible, all-powerful, omnipresent set of constraints that cannot be violated under any circumstances whatsoever. And we have no mechanism to explain why those constraints exist, or how they manage to control literally everything that exists. Some might argue that laws don't control matter. They simply describe how matter behaves. This is a seductive idea. Maybe electrons aren't obeying electromagnetism. Maybe electromagnetism is just our human description of what electrons naturally do. But this explanation collapses under scrutiny. Because if laws are merely descriptions, then they're just patterns we've noticed. And patterns can have exceptions. Patterns can break. Yet physical laws never break. Not once. Not ever. And more crucially, these laws allow us to predict the future with terrifying accuracy. You can calculate where Jupiter will be 50 years from now down to the meter. You can predict when the next solar eclipse will occur centuries in advance. You can design a spacecraft that will reach Mars months or years before it launches, and it arrives exactly where you calculated it would. That's not just description. That's prescription. The universe is bound to these laws in a way that transcends mere pattern recognition. We've built entire civilizations on the assumption that these laws will continue to hold. Every bridge, every airplane, every computer chip exists because we trust. Not hope, not assume, but trust with absolute certainty that the fundamental constants won't change tomorrow. The fine structure, constant, the gravitational constant, the mass of the electron. These numbers are the same today as they were at the dawn of time, and they'll be the same at the end of time. We bet everything on this consistency. Our technology, our science, our survival depends on it, and we have absolutely no explanation for why it should be this way. Here's what makes this question so vertigo-inducing. If you trace any chain of causation backward, you always hit the same wall. Why does water boil at 100 degrees Celsius? Because of thermodynamics. Why does thermodynamics work that way? Because of the behavior of atoms and energy transfer. Why do atoms behave that way? Because of quantum mechanics and electromagnetic forces. Why do those forces exist? Because of the fundamental laws of physics. Why do those laws exist? The question stops dead. We hit bedrock. There's no deeper why that physics can access. We can describe laws governing matter. We can even speculate about laws governing laws, meta-laws, if you will. But at some point, you reach the basement level, the ground floor of causation, and there's nothing beneath it, just laws, existing without cause, without reason, without justification. And this is why the Big Bang is not an answer. It's barely even the beginning of the question. The Big Bang tells us that the universe exploded into existence from a singularity. 13.5 Horseen 8 billion years ago. Fine. Wonderful. But the Big Bang itself obeys laws. The expansion of space, the cooling of energy into matter, the formation of the first atoms, all of this followed precise mathematical rules. The Big Bang didn't create those rules. It operated within them. So the question remains, hanging in the void, unanswerable and unavoidable. Where did the rules come from? If you stop watching now, if you close this tab and walk away, thinking you understand the origin of everything, you'll spend the rest of your life satisfied with an incomplete answer. You'll think the Big Bang explains existence, but it doesn't. It explains an event. It doesn't explain the framework that allowed that event to occur. It doesn't explain why there's order instead of chaos, why there's mathematics instead of madness, why there's predictability instead of pure random noise. And most terrifyingly of all, it doesn't explain why you can trust that when you step forward, the ground beneath your feet will obey the same laws it obeyed a second ago. What you're about to discover isn't just a better answer. It's a question behind the question, a mystery beneath the mystery. Because once you see that physical laws themselves need explaining, everything changes. The universe stops being a thing that exists and starts being a thing that obeys, and obedience without an enforcer is the most unnatural concept in existence. The speed of light is 299,792,458 meters per second, not roughly 300 million. Not almost that number, not a nice round number that would make sense if someone had chosen it arbitrarily. That exact value. Precisely that speed. No more, no less. In every direction, in every galaxy, at every moment since time began. Why? Why that number specifically? Who set the dial? And more unsettling still, why is there a dial at all? Before we go further, we need to establish something crucial, something most people never stop to consider. Physical laws are not human inventions. This isn't a philosophical technicality. It's the foundation of everything we're about to discuss. When Isaac Newton wrote down his equations for gravity, he wasn't creating gravity. Gravity had been pulling apples to the ground for billions of years before humans evolved the capacity to notice it, let alone describe it mathematically. When James Clerk Maxwell unified electricity and magnetism into a single elegant set of equations in the 1860s, electromagnetic forces had already been binding atoms together since the first moments after the Big Bang. These laws existed before Earth formed. They existed before the first star ignited. They existed in the first fraction of a second after the universe burst into being, governing the behavior of particles and forces when there was nothing around to observe them. No consciousness to measure them, no intelligence to write them down. This is what makes them so fundamentally different from human laws. Human laws are conventions. We decided to drive on the right side of the road in some countries, the left in others. We could change that tomorrow if we wanted to. We invented property rights, legal systems, social contracts. But you cannot repeal gravity. You cannot petition the universe to change the electromagnetic force. These laws are discovered, not decreed. They're constraints that were already there, woven into the fabric of reality itself, waiting for us to stumble upon them. And when we did stumble upon them, when we finally developed the tools to measure and describe them, we discovered something that should have been impossible. They're mathematical. This brings us to what physicist Eugene Wigner called the unreasonable effectiveness of mathematics in the natural sciences. It's one of the most profound mysteries in all of human knowledge, and most people have never even heard of it. Here's the puzzle. Mathematics is a language humans invented. We created algebra, calculus, differential equations, all of it, as tools to help us think about abstract relationships between numbers. Mathematics exists in our minds and on paper. It's not a physical thing. You can't stub your toe on a theorem or trap an equation in a jar, and yet, and this is where reality starts to feel like a cosmic joke. This abstract language we made up perfectly describes the physical universe. Not approximately, not kind of, perfectly. When you write down Einstein's field equations for general relativity, you're using abstract mathematical symbols to describe how space-time curves around mass and energy. These equations were written with pen and paper. They live in textbooks. They're taught to students who manipulate them with chalk on blackboards, but out there, billions of light years away, around black holes and neutron stars and colliding galaxies, space-time is actually curving exactly as those equations predict. The universe is performing calculus. It's solving differential equations in real time, constantly, everywhere, all at once. It did this for 13.8 billion years before humans existed. It will continue doing it long after we're gone. The universe doesn't need mathematicians to obey mathematics. It just does. Automatically. Perfectly. Always. How is this possible? How can abstract symbols humans invented to help us think describe, with jaw-dropping precision, the actual behavior of physical reality? It's as if you wrote a poem about love, and then discovered that the atoms in your body were literally arranging themselves according to the meter and rhyme scheme. It's as if the universe looked at our mathematical equations and said, "Yes, exactly that. That's what I'm doing. This shouldn't work." There's no reason why the abstract language of mathematics should map onto physical reality with such stunning accuracy. But it does, and nobody knows why. Let's get concrete. Let's talk about the 4 fundamental forces that govern everything in existence. Gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These aren't just important forces. They're the only forces. Every interaction between every particle in the entire universe can be reduced to some combination of these four, and each of these forces has associated with it certain constants, specific numbers that determine how strong the force is, how it behaves, how it interacts with matter and energy. These constants are not just numbers we made up to make our equations work. They're measured values. They're discovered features of reality, and they're bizarrely, unsettlingly specific. Take the fine structure constant, one of the most important numbers in all of physics. It's approximately 1 divided by 137. This constant determines the strength of electromagnetic interactions, how tightly electrons bind to atomic nuclei, how atoms interact with light, how chemistry itself works. The value is dimensionless, meaning it's not measured in meters or seconds or kilograms. It's a pure number, a ratio that exists independent of whatever units humans choose to use. And it's precisely, exactly 1 over 137.035999177. Why? Why that number? Why not 1 over 138? Why not 1 over 100? The universe doesn't offer an explanation. That's just what it is. That's what it's always been. That's what it will always be. And if it were even slightly different, if it were 1 over 150, say, or 1 over 120, chemistry would break. Atoms would behave differently. The entire structure of matter would change. You wouldn't exist. Or consider the gravitational constant, usually denoted as G. It determines the strength of gravity, the force that holds planets in orbit, that prevents stars from flying apart, that shapes galaxies and bends space-time itself. The value of G is approximately 6.1674 times 10 to the negative 11th power, measured in units of cubic meters per kilogram per second squared. Again, why that value? Why not stronger? Why not weaker? And here's where things get disturbing. If gravity were just slightly stronger, and we're talking about a difference so small it would take 18 zeros after the decimal point before you reached the first significant digit, if it were that tiny bit stronger, the universe would have collapsed back in on itself immediately after the Big Bang. No stars, no planets, no atoms even. The entire cosmos would have lasted less than a second before imploding into nothingness. If gravity were slightly weaker by the same margin, matter would never have clumped together. No stars would form, no galaxies, just an endless, cold, empty expansion of particles drifting apart forever, getting further and further from each other, until the universe was nothing but isolated atoms scattered across infinite darkness, never interacting, never building anything, never giving rise to complexity or structure or life. The strong nuclear force is even more precariously balanced. This is the force that binds quarks together to form protons and neutrons, and binds protons and neutrons together to form atomic nuclei. Without it, atoms couldn't exist. You'd just have free-floating particles unable to stick together. The strong force is, as its name suggests, incredibly powerful, but only at extremely short ranges. It dominates at distances comparable to the size of an atomic nucleus, but becomes negligible beyond that. The strength of this force is determined by another constant, and that constant is fine-tuned to an almost incomprehensible degree. If the strong force were just 1% stronger, 1% protons would bind together so tightly that hydrogen, the simplest and most abundant element in the universe, couldn't exist. No hydrogen means no water. No water means no life, at least not as we understand it. But it also means no hydrogen fusion in stars, which means no stars at all, which means no heavy elements, no planets, no anything. If the strong force were 1% weaker, atomic nuclei would fall apart. No stable atoms, no chemistry, no molecules, no structure, nothing. The weak nuclear force, responsible for certain types of radioactive decay and for the processes that power the sun, is similarly calibrated. Too strong, and the Big Bang would have converted all hydrogen into helium and heavier elements within the first few minutes of the universe's existence, leaving nothing to fuel stars for billions of years. Too weak, and stars wouldn't be able to generate the energy they need through fusion, and they'd never explode as supernovae. The cosmic forges that create most of the elements heavier than iron, including the carbon in your body, the oxygen you breathe, the calcium in your bones. Let that sink in. Every fundamental force operates at exactly the right strength to make everything possible. Not just life, not just complexity, everything. Atoms, stars, chemistry, galaxies. The fact that you're reading these words right now is the result of 4 forces operating at 4 precise strengths that allow matter to exist, structure to form, and complexity to emerge. Change any of these constants by even a fraction of a percent, and the universe becomes a barren void, incapable of producing anything remotely interesting. This is what physicists mean when they talk about fine-tuning. It's not a religious argument, it's an empirical observation. The universe appears to be balanced on a knife's edge. The constants that determine how forces behave, how particles interact, how energy and matter relate to each other, these constants occupy an almost impossibly narrow range of values that permit existence as we know it. The vast majority of possible values for these constants would result in universes where nothing happens. No stars, no planets, no atoms, no light, no time as we experience it. Just nothingness, or chaos, or some incomprehensible state where the laws themselves are so different that structure cannot emerge. And we're not talking about intelligent design here, at least not yet. We're simply stating a fact. The dials are set to very specific positions, and if they were set to almost any other positions, you wouldn't be here wondering about it. This is the anthropic principle in its most basic form. We observe these specific constants because they're the only constants that allow observers to exist. In a universe with different constants, there'd be no one to measure them. But this explanation, satisfying as it might seem on the surface, doesn't actually answer the question. It just restates it in different words. Yes, we're here because the constants allow us to be here. But why are the constants what they are in the first place? Think about it this way. Imagine you walk into a locked room. There's no door behind you. You have no memory of entering. You just find yourself there. And in this room, you notice that the temperature is exactly 20 degrees Celsius. The humidity is exactly 45%. The air pressure is exactly 1,013 millibars. The oxygen content is exactly 21%. Every single environmental parameter is set precisely to values that allow you to survive and remain conscious. You could argue, well, of course the room is set up this way. Otherwise, I wouldn't be alive to observe it. And that's true. But it doesn't explain why the room exists in the first place, or who set all those dials with such precision, or why there's a room at all, rather than empty space or solid rock, or a vacuum or a sea of lava. The anthropic principle tells you why you observe what you observe, but it doesn't tell you why there's anything to observe. The universe is a locked room, and we're examining the locks. And what we've discovered is that these locks are incredibly, suspiciously, almost impossibly sophisticated. The precision required for existence is staggering. We're not talking about rough approximations or close enough. We're talking about constants that need to be calibrated to dozens of decimal places to produce a universe where anything interesting happens. It's the difference between a billion possible combinations on a lock and finding that only one specific combination, one exact sequence of numbers, allows the door to open. And that door is the difference between existence and void. Some physicists have proposed the multiverse hypothesis to explain this fine-tuning. Maybe there aren't just four forces with four specific constants. Maybe there are infinite universes with infinite combinations of forces and constants, and we just happen to live in one of the vanishingly rare universes where the combination works. Most universes are stillborn. They either collapse immediately, expand into nothingness, or generate such bizarre physics that nothing resembling structure or complexity can form. We live in a winner universe, and we're the lottery ticket holders. But even this explanation raises more questions than it answers. Where do these infinite universes come from? What laws govern the multiverse itself? What determines which constants are possible and which aren't? You've just pushed the question up one level. You still need meta-laws, laws above laws, to explain why multiple universes can exist with different constants in the first place. And here's what keeps physicists awake at night. Predictive. We can describe all of this with mathematics. We can write down the equations that govern each force. We can measure the constants with extraordinary precision. We can predict what would happen if those constants were different. We can model universes that never existed and never will exist, just by changing a few numbers in our equations. But we cannot explain why our equations work. We cannot explain why the universe obeys mathematics at all. We cannot explain why these specific numbers were chosen, if chosen is even the right word. The universe is computing solutions to differential equations at every point in space-time, and it's been doing this since before there was anyone to notice. Mathematics is the language of reality, but we didn't write that language. We discovered it, and the more we discover, the more precise and elegant the underlying mathematics becomes. Einstein's field equations can be written on a single line. They're beautiful, symmetrical, elegant, and they describe how gravity works throughout the entire cosmos. The standard model of particle physics, the theory that describes 3 of the 4 fundamental forces and all the known particles, can be written as one incredibly dense equation. It's not simple, but it is unified. It's coherent. The universe doesn't need 1,000 unrelated rules. It needs a handful of deep principles, and everything else emerges from those principles through pure mathematical necessity. This is what physicists mean when they talk about the elegance of physical law. The universe isn't just following rules. It's following beautiful rules. Rules that have a kind of aesthetic perfection to them. And nobody knows why beauty and truth should be related at all. But here's the problem. the crack in the foundation, the glitch that threatens to unravel everything we think we understand. We've discovered that, in the quantum realm, the world of subatomic particles, of electrons and photons and quarks, the laws start to behave strangely. Not break, exactly, but glitch. Particles can be in two places at once. Causality gets fuzzy. Effects happen before causes under certain interpretations. Measurements change outcomes. The clean, deterministic, clockwork universe of classical physics dissolves into probability clouds and uncertainty principles and phenomena that should be impossible if the universe were really just a mathematical machine following rigid rules. The laws still hold, but they hold differently. They become probabilistic rather than deterministic, and this raises a terrifying possibility. Maybe the laws we've discovered aren't fundamental after all. Maybe they're just approximations, effective descriptions that work at human scales but blur and warp at the edges of reality. Maybe the universe isn't really obeying laws at all. Maybe we've just found patterns that hold most of the time, at most scales. And we've mistaken those patterns for something deeper and more permanent than they actually are. So where do the laws come from? It's the question that haunts every physicist who's ever stared at an equation and wondered why it works. And humanity has proposed answers. Brilliant answers. Answers that sound almost right, that feel like they might finally close the loop, that promise to explain everything if you just follow the mathematics deep enough. But here's what you need to understand before we dive in. Every answer spawns a new question. Every explanation requires its own explanation. It's turtles all the way down, except the turtles are made of questions, and beneath the questions are more questions. And at some point, you have to decide whether to keep digging or accept that maybe, just maybe, there's no bottom to reach. Let's examine the leading theories, one by one, and see how far they get us before they hit their own walls. Theory 1. Everything is math. This is the mathematical universe hypothesis, championed most vocally by physicist Max Tegmark at MIT. It's an idea so radical that even most physicists think it goes too far. But it's also one of the only theories that attempts to fully eliminate the mystery rather than just relocate it. Here's the core claim. Physical laws aren't separate from physical reality. They don't govern the universe from outside like some external rule book. Instead, the universe is mathematics, not described by mathematics or governed by mathematics, but literally made of mathematics. You're not made of atoms that obey mathematical laws. You're made of the mathematics itself. The atoms are just how the mathematics appears to you, because you're also mathematics examining itself from the inside. Think about what this means. In Tegmark's view, mathematical structures don't need to be created because they exist necessarily. By definition, the number 2 exists. You can't uncreate the number 2. It's not a physical thing that could be destroyed or that needs any substrate to exist upon. It simply is, as a pure abstraction. And it would still be true even if the entire physical universe vanished. 2 plus 2 equals 4, whether or not there are any objects to count. That's the nature of mathematical truth. It's independent of physical reality. Now extend that logic. If simple mathematical structures like numbers exist necessarily, then complex mathematical structures also exist necessarily. A dodecahedron exists as a mathematical object whether or not any physical dodecahedron has ever been built. The equations that describe a certain kind of system exist, whether or not that system is physically instantiated anywhere. And if you take this to its logical extreme, all possible mathematical structures exist, including the mathematical structure that looks, from the inside, exactly like our universe. In this view, the Big Bang wasn't the creation of something from nothing. It was the discovery of a particular mathematical structure that has the property of self-awareness embedded within it. We are patterns within the mathematics, localized regions where the equations become complex enough to generate consciousness and ask questions about themselves. Physical laws aren't rules imposed on matter. They're simply descriptions of the mathematical relationships that define the structure we inhabit. Asking why the universe obeys laws is like asking why triangles have three sides. It's definitional. It's what it means to be this particular mathematical structure. The appeal of this theory is obvious. It solves the infinite regress problem. You don't need to explain where mathematics comes from because mathematics doesn't come from anywhere. It's not contingent on anything else. It just exists, necessarily and eternally, as the only thing that could be called truly fundamental. And if our universe is one such mathematical structure among the infinite possible mathematical structures, then the laws of physics are simply the internal logic of that structure. They don't need an external creator or an enforcement mechanism. They're just what it means to be this particular pattern of mathematical relationships. But here's where the theory gets uncomfortable. If all mathematical structures exist, then all possible universes exist. Not just our universe with slightly different constants, all possible universes with all possible laws, including universes where the laws are completely different, where time doesn't exist, where there are 17 dimensions instead of 4, where the very concept of particles and forces is replaced by something utterly alien and incomprehensible, and we exist in this one because it's the only one we could exist in. Most mathematical structures don't generate consciousness. Most universes are dead on arrival. We're not special. We're just statistically inevitable in an infinite ensemble. Somewhere in the space of all possible mathematical structures, there had to be one that looks like this. And that's us. We're the universe that got lucky enough to be interesting. The problem with this theory is that it explains everything and therefore explains nothing. Yes, if all mathematical structures exist necessarily, then ours exists necessarily. But why does existence feel like this? Why does being a mathematical structure feel like being alive, like having sensations and thoughts and experiences? Mathematics is abstract. Conscious experience is vivid, immediate, undeniably real in a way that pure abstraction isn't. How does the number 2 feel anything? How does an equation hurt or hope or wonder? Tegmark's hypothesis solves the origin of laws but stumbles on the origin of consciousness, of qualia, of the raw experiential fact of what it's like to be something rather than to simply be described by something. Theory 2. Everything is chance. Welcome to the multiverse. Or more precisely, eternal inflation. The idea that our Big Bang wasn't the Big Bang, but merely one bubble in an infinite foam of universes constantly spawning, expanding, and evolving. In this framework, the laws of physics aren't universal, they're local. Each universe bubble gets its own set of laws, its own values for the fundamental constants, its own arrangement of forces and particles. Most universes get bad rolls. Their constants don't line up. Atoms can't form, or they form but immediately decay. Or gravity is so strong that everything collapses, or so weak that nothing clumps together. These universes exist for a moment. If moment even means anything when time itself might not function properly. And then they fade into irrelevance, barren and empty, and utterly incapable of producing anything that could wonder about its own existence. But in an infinite multiverse, with infinite bubble universes constantly being created, every possible combination of laws gets tried, every possible value for every constant, every possible strength for every force. Most combinations produce nothing, but some combinations, rare, precious, vanishingly improbable combinations, produce universes where atoms are stable, where stars can form, where chemistry works, where complexity can emerge. We live in one of those universes, not because it was designed, not because the laws were chosen carefully, but because it's the only kind of universe where beings capable of asking, "Why are the laws this way?" could arise right now in another universe. You don't exist, not because you died or never were born, but because the laws of physics there made carbon impossible. The strong force is wrong. Atoms don't bind. Chemistry never happened. You're lucky, incomprehensibly lucky, to be bound by these laws instead of those. This is the anthropic principle on steroids. The fine-tuning of our universe isn't suspicious. It's inevitable. If there are infinite universes, then even the most improbable combinations must occur somewhere. And only in the universes where the combination works will there be anyone to observe it and find it remarkable. It's like dealing an infinite number of poker hands. Eventually, you'll get a royal flush, and the person who gets it will marvel at the odds, not realizing that someone had to get it eventually. We're the royal flush. We're the winners of a cosmic lottery we didn't know we'd entered. The appeal here is that it removes the need for design or purpose. The laws don't need to be created by anything. They're just one possibility among infinite possibilities, and we happen to inhabit the possibility that works. The fine-tuning isn't evidence of intentionality. It's evidence that we're sampling from a biased pool. We can only observe universes capable of producing observers. But the problems are legion. First, the multiverse is, by definition, unobservable. If other universes exist beyond our cosmic horizon, we can never reach them, detect them, or verify their existence. The theory is unfalsifiable, which some argue disqualifies it from being science at all. It makes predictions we can never test. Second, even if the multiverse exists, something has to generate it. Eternal inflation requires a mechanism, a field, a process, a set of rules that allows universes to bud off from each other. And those rules are laws of multiverse physics. So you've just pushed the question back one level. Yes, our laws might be random, but the meta-laws that allow for eternal inflation and determine which constants are possible and how universes spawn, where do those come from? Third, the anthropic principle, while clever, is deeply unsatisfying. It doesn't explain why there's a multiverse in the first place. It doesn't explain why existence itself is structured in a way that allows for multiple universes with different laws. It just says it is, and we're in one of them. That's not an explanation. That's a restatement of the mystery wearing a mathematical disguise. Theory 3. Everything is survival. Now we get strange quantum Darwinism, or more broadly, cosmological natural selection. The idea here is that universes don't just exist, they reproduce, and the ones that survive and proliferate are the ones with stable laws. Unstable law sets collapse. They can't sustain themselves. They die in infancy, if death is even the right metaphor for a universe that never fully forms. But universes with stable laws, laws that allow for structure, for complexity, for processes that unfold over time, those universes persist, and if they can somehow generate offspring universes through mechanisms like black hole formation or quantum tunneling, then the offspring inherit the laws of the parent with slight variations, like mutations in DNA. Over countless iterations, across incomprehensible spans of time, the multiverse evolves toward law sets that work, that permit stability, that allow for lasting structure. In this view, fine-tuning isn't luck or design, it's evolution. We live in a universe descended from a long line of successful universes, universes that didn't collapse, didn't dissolve, didn't spawn offspring with fatal flaws. Our laws are the way they are because they're survivors. They've been naturally selected for stability. The vast majority of possible laws were tried at some point in the cosmic past and failed. They didn't produce universes that lasted long enough to reproduce. What we observe is the end point, or at least a point along the way, of a vast evolutionary process where physical laws themselves are the phenotype being selected. This is seductive because it borrows the most successful explanatory framework in biology and applies it to cosmology. Evolution by natural selection explains the apparent design of living organisms without requiring a designer. Maybe it can do the same for the apparent design of physical laws. The fine-tuning isn't a miracle. It's the predictable outcome of selection pressure. Of course, we observe stable laws. The unstable ones didn't make it to the present, but the theory has deep problems. First, it requires a mechanism for universe reproduction. And while some physicists have proposed that black holes might spawn baby universes with slightly altered constants, this is wildly speculative. We have no evidence of universe reproduction. We can't test it. We can't observe it. It's an extrapolation from a process we understand, biological evolution, to a domain where we don't even know if the necessary preconditions exist. Second, even if universes do evolve, you still need an initial condition. You need a first generation of universes with some set of laws, and you need meta-laws that govern how universes reproduce and how laws mutate across generations. Where do those meta-laws come from? Third, and most troubling, is that natural selection requires variation, reproduction, and differential survival. But in what medium do universes vary, reproduce, and survive? What's the environment they're adapting to? Evolution needs ecological context. Without it, the metaphor breaks down. You're just using the word evolution to describe something that might not be evolutionary at all. Theory 4. Everything is geometry, string theory, loop quantum gravity. These are the bleeding edge of theoretical physics, the frameworks that attempt to unite quantum mechanics and general relativity, to explain not just what the laws are, but where they come from and why they have the structure they do. In string theory, particles aren't point-like objects. They're tiny vibrating strings, and the different vibrational modes of these strings correspond to different particles. An electron is a string vibrating one way. A quark is a string vibrating another way. The forces themselves emerge from how strings interact, how they split and join and dance through space. And the laws of physics, they're determined by the geometry of the extra dimensions these strings inhabit. Yes, extra dimensions. String theory requires 10 or 11 dimensions to be mathematically consistent, but we only observe 4, 3 of space, 1 of time. The other dimensions are supposedly compactified, curled up so small that we can't detect them directly. And the precise shape of those compactified dimensions, their topology, their curvature, their geometry, determines what laws of physics emerge in the 4-dimensional world we inhabit. These shapes are called Calabi-Yau manifolds, and they're exquisitely complex, 6-dimensional objects that twist and fold in ways that make your brain hurt just trying to visualize them. There are millions of possible Calabi-Yau manifolds, maybe infinitely many, and each one would produce a different set of physical laws. The constants we observe, the strength of forces, the masses of particles, are all consequences of which Calabi-Yau manifold we're stuck with. In this picture, the laws aren't fundamental. They're emergent. They arise from deeper geometrical structure, from the shape of hidden dimensions that exist at scales trillions of times smaller than an atom. Asking why the laws are the way they are is like asking why a particular musical instrument produces the sounds it does. The answer is, because of its shape. Change the shape, change the sounds, change the geometry of the compactified dimensions, change the laws of physics. Loop quantum gravity takes a different approach, but arrives at a similar destination. Instead of strings, it proposes that space-time itself is quantized at the smallest scales, not smooth and continuous, but made of discrete chunks, a kind of quantum foam where space and time are woven from fundamental loops of area and volume. The laws of physics emerge from how these loops connect and interact, from the network structure of space-time at the Planck scale. Gravity isn't a fundamental force. It's an emergent property of quantum geometry. The constants aren't arbitrary. They're determined by the underlying structure of space itself. These theories are beautiful. They're mathematically elegant. They offer the tantalizing possibility that all the seemingly arbitrary features of our universe, all the constants, all the forces, all the particles, can be derived from a single, unified framework. You don't need to ask why the electron has the mass it does. The mass falls out of the geometry. You don't need to ask why the forces have the strengths they do. The strengths are consequences of the shape of hidden dimensions or the structure of quantum space-time. Everything emerges from geometry, and geometry is just there. It's the most fundamental thing. It's what existence means at the deepest level. But, and this is a monumental but, string theory and loop quantum gravity are incomplete. Neither has been experimentally verified. Neither makes predictions we can currently test. They're mathematical frameworks that work on paper, but have yet to make contact with reality in a way that would convince skeptics they're more than elegant speculation. And even if they're correct, even if one of them turns out to be the true theory of everything, they don't actually answer the ultimate question. They just relocate it. Yes, the laws emerge from geometry. Fine. But where does the geometry come from? Why do strings exist? Why does space-time have the structure it does? Why are there Calabi-Yau manifolds at all? And why is our universe compactified into one shape instead of another? You've explained the laws in terms of deeper laws. You've explained physics in terms of math. but you still haven't explained why there's anything at all, or why the anything that exists takes this particular form, rather than some other form or no form whatsoever. Every theory hits the same wall. The mathematical universe hypothesis says reality is math, but it can't explain consciousness, or why this math rather than other math. The multiverse says we got lucky, but it can't explain where the multiverse comes from or what generates it. Quantum Darwinism says laws evolved, but it can't explain the meta-laws that govern evolution or the initial conditions that started the process. String theory and loop quantum gravity say laws emerge from geometry, but they can't explain where geometry comes from or why it has the properties it does. Do you see the pattern? Every answer is also a new question. Every explanation requires its own explanation. Push on any theory hard enough, and it either admits it doesn't have a final answer, or it smuggles in assumptions about what's fundamental without justifying those assumptions. The turtles go down forever, and at some point you have to choose. Either there's an infinite regress of explanations, which means we'll never reach the bottom, and the question why can never be fully answered. Or there's something truly fundamental that exists without explanation, without cause, without reason, something that just is, brute fact, irreducible. And that's the real nightmare. Because if the laws have always existed, if they're eternal and uncaused, and simply part of the furniture of reality in a way that requires no further justification, then the universe isn't just indifferent to us, it's incomprehensible at the deepest level. There's a floor beneath which our questions can't penetrate, a bedrock of existence that doesn't answer to logic or causation or reason. It just is. And we're left standing on that bedrock, staring down, realizing that why might not have an answer, not because we're not smart enough. Not because we haven't discovered the right theory yet, but because reality doesn't owe us an explanation. The laws are the way they are, and that's all there is to say. And maybe, just maybe, that's the most terrifying possibility of all. Physics has taken us as far as it can go. We've examined the laws themselves, measured their constants, traced their implications, theorized about their origins. We've descended through string theory and quantum geometry, through multiverses and mathematical structures, and at every level we've hit the same impenetrable wall. Science can tell us what the laws do. It can even tell us, speculatively, how they might arise from deeper structures. But it cannot tell us why there are laws at all. Why there's structure instead of chaos. Why existence itself has this particular flavor of comprehensibility. For that, we need to leave the laboratory and enter a far stranger realm, philosophy. And once we cross that threshold, once we start asking not just how, but why, in the deepest possible sense, we enter what can only be described as an abyss. An abyss where questions multiply faster than answers, where certainty dissolves, and where the very ground beneath your conception of reality begins to crack and fall away. Let's start with the most ancient and seductive philosophical position on the nature of laws. Platonism, named after Plato. Though the idea has evolved far beyond what the ancient Greek actually proposed, modern Platonism about physical laws holds that these laws exist in a realm of abstract objects, independent of physical reality entirely. In this view, the laws of physics are not made of matter or energy. They don't exist in space-time. They're not properties of the universe. Instead, they exist in a kind of eternal, unchanging, non-physical realm, what Plato called the realm of forms, and physical reality is merely a shadow or reflection of these perfect abstract truths. The number 2 exists in this realm. The concept of circularity exists there. Mathematical truths exist there, and so do the laws of physics. They've always existed. They'll always exist, and they exist whether or not any physical universe instantiates them. Think of it like this. The blueprint for a building exists before the building is constructed. The blueprint doesn't need the building to exist. It's an abstract plan, a set of specifications and relationships. The building is built according to the blueprint. But the blueprint itself is independent of whether any building actually gets built. In Platonic thinking, the laws of physics are the blueprint, and our universe is one instantiation of that blueprint. The laws existed before the Big Bang, they exist now, and they'll exist after the universe ends. They're not contingent on the universe. The universe is contingent on them. You can't have a physical cosmos without the laws that govern it. But you can have laws without a cosmos. They sit there in abstract space, eternal and perfect, waiting to be enacted, or perhaps already enacted in countless universes across dimensions we can't access or conceptualize. This view has profound implications. If the laws are abstract objects existing independently, then they're not created. Creation applies to physical things, to things that come into being at some moment in time. But abstract objects are timeless. They don't come into being. They simply are. Mathematical truths aren't created. 2 + 2 = 4 before the universe existed, and will equal 4 after the universe ends. If physical laws have the same status as mathematical truths, then asking what created the laws is a category error, like asking, what does blue taste like? Or where is Tuesday located? The question doesn't make sense because it's applying concepts that only work for temporal, physical objects to something that exists outside of time and physicality. But here's where Platonism gets uncomfortable. If the laws exist in some abstract realm, what exactly is that realm? Where is it? How does it relate to physical reality? How do abstract, non-physical laws reach down, so to speak, and constrain physical objects? You've just created a new mystery to solve the old one. You've explained the ubiquity and unchanging nature of physical laws by positing an entire other realm of existence, a realm we can never observe or detect because it's not physical. And now you need to explain how that realm works and how it connects to ours. You've solved the problem of where laws come from by saying they don't come from anywhere. They exist eternally in abstract space. But now you need to explain why abstract space exists, what it means for something to exist if it's not physical, and how non-physical abstractions can have causal influence over physical reality. The mystery has shifted, but hasn't vanished. Now, consider the opposite position. Nominalism. Is the view that abstract objects don't exist at all. There is no Platonic realm. There are no perfect forms hovering in some mathematical heaven. There's just the physical universe. Matter, energy, space-time, particles, fields, and our descriptions of how that universe behaves. Physical laws, in the nominalist view, aren't real entities. They're just patterns we've noticed, regularities we've observed, linguistic and mathematical tools we've invented to summarize and predict behavior. When we say objects with mass attract each other according to the inverse square law, we're not describing some invisible entity called gravity that exists independently. We're just compressing a lot of observations into a tidy sentence. The law of gravity is shorthand. It's a description, not a thing. In this framework, asking where laws come from is like asking where the equator comes from. The equator doesn't come from anywhere. It's not a physical object. It's a human convention, a line we drew on maps to help us navigate. You can't stand on the equator. There's nothing actually there except air and water and land. Similarly, physical laws don't come from anywhere because they're not real in the ontological sense. They're useful fictions, conceptual tools, the best compression algorithms we've found for reality's behavior. And if the universe operated differently, if particles behaved in chaotic, unpredictable ways, there simply wouldn't be laws to discover. We impose the concept of law onto nature. Nature doesn't actually contain laws. This is liberating in some ways. It eliminates the mystery entirely. There's no metaphysical puzzle about where laws come from because laws aren't real things that need origins, but it's also deeply unsatisfying. Because if laws are just our descriptions, then why do our descriptions work so well? Why can we predict the future with such precision if we're just making up narratives about patterns? Why does the universe behave in predictable, mathematically elegant ways if there's nothing actually enforcing that behavior? Nominalism explains away the mystery by denying that there's anything to explain. But in doing so, it creates a new puzzle. The puzzle of why reality is so stubbornly law-like if there are no actual laws, only descriptions. It's like saying, there's no such thing as justice, only our descriptions of fair behavior, and then being baffled when human societies across all of history independently converge on similar notions of fairness. The pattern is real even if you deny the abstraction. Then there's modal realism, the brainchild of philosopher David Lewis, and it's arguably the most radical position in all of metaphysics. Lewis proposed that all possible worlds actually exist, not as mathematical abstractions, not as hypothetical thought experiments, but as fully real, concrete universes, every bit as real as our own. Right now, there exists a universe where you made different choices this morning. There exists a universe where you were never born. There exists a universe where the laws of physics are different, where gravity is stronger, where electrons have more mass, where time runs backward. There exists a universe where the concept of particles doesn't even apply, where reality is so alien that we lack the cognitive categories to describe it. Every possible configuration of every possible law in every possible universe exists, concretely and actually, scattered across modal space, the space of all possibilities. In this view, our laws aren't special. They're just the laws of our world. Other worlds have other laws. The fine-tuning isn't fine-tuning, it's just selection bias. We observe these specific laws because we exist in a world where these laws happen to obtain. In worlds with different laws, different kinds of beings observe those laws. Or no beings observe anything because those laws don't permit consciousness. The question, why these laws, dissolves. There's no why. All possible laws are instantiated somewhere. We're in this one. That's the only explanation needed. Asking why we observe these particular laws is like asking why you were born in this particular century. You had to be born somewhere, somewhen. It's not a cosmic mystery. It's just where you happen to be in the space of all possibilities. Modal realism solves many philosophical problems elegantly. It explains counterfactuals, statements about what could have been, by saying they're literally true in other worlds. It explains possibility and necessity. Something is possible if it's true in some world, necessary if it's true in all worlds. And it eliminates the need to explain our laws specifically, because all laws exist somewhere. But it does so at a staggering ontological cost. You have to accept that infinite universes exist, that they're just as real as ours, that there's no privileged actual world, and that most of modal space is filled with worlds far stranger and more numerous than the relatively orderly cosmos we inhabit. And even then, even if you accept this vast proliferation of worlds, you still need to explain why there's modal space at all. Why does possibility exist? Why are there multiple ways things could be, rather than one fixed way things must be? You've eliminated the mystery of our laws, but replaced it with the mystery of why there's a landscape of all possible laws. Now let's descend deeper. Let's talk about necessity versus contingency, one of the most fundamental distinctions in all of philosophy. Something is necessary if it couldn't be otherwise. 2 plus 2 equals 4, necessarily. There's no possible world where 2 plus 2 equals 5. A triangle has 3 sides, necessarily. If it didn't, it wouldn't be a triangle. These truths are necessary because they follow from the definitions and logical structure of the concepts involved. Something is contingent if it could have been otherwise. You're reading this right now, but you could have been doing something else. The Earth has 1 moon, but it could have had 2, or none. These facts are contingent. They happen to be true, but they're not necessarily true. They depend on specific circumstances that could have been different. So which are physical laws? Necessary or contingent? If the laws are necessary, then they couldn't be any other way. The universe couldn't have different laws. There's no possible world where gravity works differently, where electrons have different charges, where the speed of light is faster or slower. The laws we observe are the only laws that could ever exist, in this universe or any other. They're as inevitable as mathematics, as unavoidable as logic. This would explain why they exist. They exist necessarily. And necessary things don't need further explanation because they couldn't fail to exist. But it also raises terrifying questions. Why are these specific laws necessary? What makes them inevitable? Is there some deep logical structure that forces reality to take this exact form and no other? And if so, what is that structure, and why does it have the properties it does? You've eliminated contingency, but at the cost of making the laws seem like a cosmic straitjacket, an inescapable logical prison that reality is trapped within. If the laws are contingent, then they could have been different. There's no deep necessity to them. They just happen to be this way in our universe, but they could have been otherwise in other universes or even in our own universe if initial conditions had been different. This preserves the intuition that the laws are fine-tuned, that it's remarkable and somewhat miraculous that they take the specific values they do. It allows for the possibility of a multiverse with different law sets, or a creator who chose these laws from among many options. But it also means we're living in cosmic randomness. If the laws are contingent, then they're essentially arbitrary. There's no reason they're this way instead of some other way. They just are. You're not made of matter governed by deep necessity. You're made of matter governed by rules that happen to obtain, but could easily have not obtained. And in that case, you wouldn't exist. You're an accident in the space of all possible configurations of reality. And that's existentially destabilizing in a way that's hard to fully articulate. Here's where philosophy reaches its breaking point. The principle of sufficient reason, articulated most famously by Gottfried Wilhelm Leibniz in the 17th century. The principle states that everything must have a reason, a sufficient explanation for why it is the way it is, and not some other way. Nothing happens without a cause. Nothing exists without a reason for its existence. For every fact, there must be an explanation. This seems obvious. It's how we think. It's how we do science. We assume that if something is true, there's a reason it's true. And if we investigate deeply enough, we can find that reason. But apply this principle to physical laws and watch what happens. If the laws must have a reason, then there must be something that explains why they exist and why they take the form they do. That explanation might be another set of deeper laws, or it might be a creator, or it might be some logical necessity. But there must be something. However, whatever explains the laws must itself have a reason, because the principle of sufficient reason applies to everything. So you need a reason for the reason, and a reason for that reason, and so on, indefinitely. Every explanation requires its own explanation. The chain never terminates. You get an infinite regress, a staircase descending forever into darkness. And at no point do you reach a final answer that doesn't itself demand justification. Philosophers call this the cosmological argument when they're arguing for the existence of God. There must be a first cause, an unmoved mover, something that exists necessarily and doesn't need an explanation because it's self-explanatory. Physicists call it turtles all the way down when they're being flippant about infinite regress. But what we should call it is this: no one knows, and it might be unknowable. Because either the principle of sufficient reason is true, and there's an infinite regress of explanations with no foundation, or the principle is false, and some things just exist without reason. And we have to accept brute facts, facts that have no explanation, that simply are, and we're not entitled to ask why. If the laws are brute facts, if they exist without reason, without cause, without justification, then they're more fundamental than anything else in existence. They're more fundamental than God, because even God, if God exists, would presumably obey logic, obey certain conceptual constraints, operate within some framework of possibility and necessity. But the laws just are. They don't answer to anything. They're the ground floor of reality, and beneath them is nothing but void. And here's the existential punch. If the laws have no creator, no cause, no reason, then neither do you. You think you're a human made of atoms, but atoms are governed by laws. So you're not really made of matter. You're made of rules. You are the laws, manifesting in a particular configuration that calls itself a person, that has thoughts and feelings and the illusion of agency. But underneath, at the deepest level, you're just a pattern that obeys rules that themselves obey nothing. You're contingent all the way down, and the foundation you're standing on isn't solid ground. It's an arbitrary set of constraints that could have been different, and in other universes are different, meaning you, in any essential sense, is just a local eddy in the flow of mathematical relationships that happen to exist here, but not there. Most people never think about this. They live and die assuming reality is supposed to make sense, that existence has a reason, that if you dig deep enough, you'll find solid ground. But the truth, or at least the possibility we have to contend with, is that reality doesn't make sense. Not in the ultimate sense, not in the way we want it to. It's not supposed to be anything. It just is. And just is the least satisfying answer humans have ever encountered. Which is why we keep inventing better answers, more elaborate answers, answers that push the mystery back one more level but never actually eliminate it. The philosophical abyss isn't the discovery that we don't know where the laws come from. The abyss is the realization that maybe where and come from are the wrong categories entirely. Maybe laws don't come from anywhere because coming from implies causation, and causation is something that happens within the laws, not something that explains the laws. Maybe the question itself is malformed, like asking, what's north of the North Pole? The North Pole is the northernmost point. There is no north of it. Similarly, maybe laws are the fundamental-most aspect of reality, and there is no deeper level of explanation. You've reached the edge. Beyond this, there are no more turtles, just the abyss staring back, indifferent to your need for answers. But here's what should keep you awake tonight. There is one more option, one possibility we haven't explored yet. What if the laws didn't emerge from anything, and they're not eternal brute facts, and they're not necessary features of logic? What if they were chosen? And if they were chosen, by what, and for what purpose? Right now, as you process these words, there's a non-zero probability that your code, not metaphorically, not as some poetic comparison between neural patterns and computer programs, literally lines of code, algorithms executing in a substrate you cannot detect, following rules written by something that exists outside your reality. Your memories might be data structures. Your thoughts might be subroutines. Your sense of existing, of being a continuous self moving through time, might be the subjective experience of a program that has been designed to believe it's real. And the laws of physics? They're not laws at all. They're software, the operating system of a simulation so sophisticated that it includes within itself entities capable of wondering whether they're simulated. This is simulation theory, and it's not fringe speculation anymore. Philosophers take it seriously. Physicists calculate its probability. Tech entrepreneurs publicly state they believe it's more likely than not that we're living in a computer simulation. The argument goes like this. If it's possible to create realistic simulations of universes, and given the exponential growth of computing power, it seems likely that advanced civilizations will eventually have this capability. Then those civilizations will create many such simulations, potentially millions or billions of simulated universes for every one real universe. If that's the case, then by pure statistics, you're far more likely to be living in one of the simulated universes than in the one original reality. There's only one base reality. There are countless simulations. Do the math. Odds are you're in a simulation. If this is true, then the laws of physics are just code. Gravity isn't a fundamental feature of reality, it's a subroutine in the physics engine. The speed of light isn't an ultimate limit. It's a computational constraint. The maximum processing speed the simulator can maintain while rendering your universe. The fine-tuning of constants? Not a cosmic coincidence. It's intentional design. The programmer set those values deliberately. the way a game designer balances parameters to make a game challenging but playable. You exist in a universe where the constants are what they are because someone set them that way. The laws don't need an explanation beyond "that's how the code was written." This seems to answer everything. Where do laws come from? They come from the simulator. Why are they mathematical? Because they're literally algorithms. Why do they never break? Because, bugs aside, well-written code doesn't spontaneously violate its own rules. The enforcement problem vanishes. Laws are enforced the way software rules are enforced, not by cosmic police, but by the substrate that executes the code. An electron can't disobey the electromagnetic force, for the same reason a character in a video game can't walk through walls the programmer didn't make intangible. The action isn't permitted by the underlying architecture, but here's where the recursion begins, where the satisfying answer starts to crumble. If we're in a simulation, the simulator exists in a universe with its own laws. Laws that govern computation, that allow for complex information processing, that permit the existence of beings intelligent enough to run universe-scale simulations. Where do those laws come from? You haven't solved the problem. You've just moved it up one level. Maybe the simulator is also in a simulation. Maybe it's simulations all the way up. An infinite tower of nested realities, each one running simulations of the level below. But at some point, there has to be a base reality. The bedrock universe that isn't simulated, that actually exists in some fundamental sense. And that universe has laws. Real laws. Laws that aren't code because there's no deeper substrate running the code. And we're back where we started. Where do those laws come from? The simulation hypothesis is seductive because it gives us a creator without requiring us to call it God. It's technologically plausible. It doesn't invoke the supernatural. It just says, your universe is a program, and somewhere, something is running it. But it doesn't actually answer the ultimate question. It defers it. It says, our laws come from the simulator's laws, but it can't tell you where the simulator's laws come from without invoking another simulator and another, infinitely. At some point, you hit the same wall. Laws that exist without explanation, without prior cause, without anything deeper to ground them in. Now let's talk about the designer. Not the religious conception, not yet, but the abstract philosophical possibility. What if something intelligent, something with intentions and goals and capabilities far beyond anything we can comprehend, deliberately constructed this universe and its laws? Call it a cosmic architect, an engineer of reality, something that looked at the space of all possible laws, evaluated which combinations would produce interesting results, and chose this set specifically. The fine-tuning isn't an accident, and it's not statistical luck across infinite universes. It's purpose, design, selection. This explains the precision. It explains why the constants are what they are. They were chosen. The designer wanted atoms, so it set the strong nuclear force to a value that allows atomic nuclei to form. It wanted stars, so it calibrated gravity. It wanted complexity, so it arranged the forces in a way that permits chemistry, evolution, consciousness. The laws exist because they were instantiated by an intelligence with the power to instantiate laws. Where do laws come from? From a designer that exists outside the system, that has the capacity to create systems, that is in some sense prior to and more fundamental than the universe it creates. But, and you saw this coming, what laws govern the designer? If the designer can create universes, If it can set constants and define forces, it must have capabilities. And capabilities imply structure. Structure implies rules. Even if those rules are nothing like our physics, even if they're so alien we lack the concepts to describe them, the designer must operate within some framework. It must have a nature. That nature must be definite rather than arbitrary. The designer can do certain things and can't do others. Otherwise, it wouldn't be a designer. It would be formless potential, indistinguishable from nothing. So what defines the designer's nature? What constrains its capabilities? What are the meta-laws that determine what a designer can do? Some might argue the designer is God, and God is beyond laws, outside of constraints, omnipotent in the truest sense. God doesn't operate within a framework. God is the framework. God doesn't obey rules. God defines what rules are possible. But this creates a logical paradox. If God is truly beyond all constraints, then God operates without any defining characteristics, because characteristics are constraints. To be X is to not be Y. To have a nature is to have limits, even if those limits are far beyond anything we can conceive. And if God has no nature, no defining characteristics, nothing that makes God what God is rather than something else, then in what sense does God exist at all? You've made God so transcendent that God becomes indistinguishable from a formless void, from nothing itself. Or you could say, God is self-caused, the one thing that explains itself, that contains within its own nature the reason for its existence. But self-causation is deeply problematic. It means something brings itself into being, which implies it exists before it exists to cause itself. It's a temporal paradox masquerading as metaphysics. And even if you resolve the temporal issue by saying God is eternal and never came into being, you still haven't explained why God has the nature God has, rather than some other nature. Why God can do these things and not those things. Why omnipotence takes this form instead of some other form or no form at all. Here's the paradox distilled. If God created the laws, who created God's laws? If you say God is beyond laws, you've just admitted that some things can exist without laws, without rules, without constraints. But if some things can exist without laws, if lawless existence is possible, then why invoke God at all? Why not just say the universe exists without laws at its foundation, that laws emerge somehow from deeper chaos or from pure mathematical necessity or from nothing at all? You've conceded that lawless existence is metaphysically possible. Once you've conceded that, the designer becomes unnecessary. The universe could have the same property you're attributing to God, existing without prior explanation, grounding itself, being the bedrock beyond which there are no more questions. Now we descend into true madness. Boltzmann brains. This is where statistical mechanics meets existential horror, where probability calculus produces nightmares. The idea originates from Ludwig Boltzmann's work on thermodynamics and entropy in the 19th century. But its implications have only recently been fully explored, and they're profoundly disturbing. Here's the setup. The universe tends toward disorder. Entropy increases. Over enormous timescales, everything decays into a state of maximum entropy. Heat death, where all energy is evenly distributed, where no structure remains, where nothing happens because there's no energy gradient to drive any process. But even in this heat-death state, quantum fluctuations still occur. Randomly, constantly, virtual particles pop in and out of existence. Tiny regions of space briefly have lower entropy purely by chance before dissipating back into the void. Now, most of these fluctuations are small. They produce nothing interesting. But given infinite time, every possible fluctuation must occur eventually, including fluctuations large enough and ordered enough to spontaneously produce a human brain, complete with memories, thoughts, and the subjective experience of existing in a universe with laws. This is a Boltzmann brain, a brain that pops into existence fully formed from a random quantum fluctuation, persists for a brief moment, and then dissolves back into entropy. From the inside, this brain has no way of knowing it's a Boltzmann brain. It has memories of a past that never happened. It perceives a universe that doesn't exist. It believes it's a person living in a lawful cosmos when it's actually a random fluctuation in heat-death void, persisting for fractions of a second before dissolving. Here's why this is relevant to our question about laws. If the universe eventually reaches heat death, and if heat death persists for infinite time, then the overwhelming majority of observer moments when something conscious exists to observe anything, will be Boltzmann brains, not real observers in structured universes. There's only a finite period when real observers exist, while the universe has structure and laws. But there's an infinite period of heat death producing infinite Boltzmann brains. By pure statistics, if you're an observer, you're far more likely to be a Boltzmann brain than a real person. Your memories are fake. Your universe is a hallucination. And the laws? They're not real. They're part of the illusion generated by your randomly fluctuating brain, which happens to have formed with memories and perceptions that include belief in physical laws. The Boltzmann brain problem is one of the most unsettling implications of modern cosmology, and physicists genuinely worry about it because it threatens to undermine all empirical knowledge. If you're more likely to be a Boltzmann brain than a real observer, then your observations can't be trusted, which means all of science, built on observations, becomes suspect. You think you've discovered laws through careful measurement and experimentation, but actually you're a fleeting pattern in cosmic noise that happens to have the false memory of doing science. The laws don't exist. You don't exist, not in any sustained sense. You're a statistical anomaly that will be gone before you finish processing this thought. The only way to avoid this conclusion is to argue that the universe won't end in heat death, or that infinite time doesn't allow for infinite fluctuations, or that something about the structure of reality prevents Boltzmann brains from forming, even though the math says they should. But these are desperate measures, patches to avoid an implication that's mathematically sound if disturbing. And here's the recursive nightmare. Even if you're not a Boltzmann brain, even if you're a real observer in a real universe with real laws, you can never be certain. You could always be a fluctuation that just happened to form with the specific configuration of neural states that produce the sensation of certainty. Doubt becomes irresolvable. Solipsism becomes statistically favored. Do you see the pattern yet? Every explanation is a reframing. Simulation theory says laws come from code, but code requires a substrate with its own laws. The designer hypothesis says laws come from an intelligent creator, but the creator requires a nature governed by meta-laws. Boltzmann brains suggest laws might be illusions, but even random fluctuations require probability laws that determine which fluctuations are possible. Every answer opens another question. Every solution reveals itself to be a deferral. The mystery doesn't get solved. It gets relocated, renamed, rephrased, but never eliminated. And maybe this is the thought that should genuinely terrify you. Maybe that's not a bug. Maybe it's a feature. Maybe the question, where do laws come from, is fundamentally unanswerable. Not because we're too stupid, or because we haven't discovered the right theory yet, but because reality itself is incomplete. Because existence doesn't have a foundation. Because if you dig deep enough, you don't find bedrock. You find an infinite regress, or a circular loop, or a brute fact that refuses justification, or a void where answers should be but aren't. We're about to enter the final layer. This is where science, philosophy, and something that might be madness blur together. Where the question eats itself. Where the search for answers leads to the discovery that some questions might be malformed at their core, that why might not always have a response, that reality could be, at its deepest level, arbitrary. If you stop now, you'll never know what's on the other side. But if you continue, be warned. The other side might be an abyss that stares back and offers nothing but silence. We've reached the deepest layer. This is the question beneath all questions, the paradox that eats every answer, the place where even the most brilliant minds have stalled and turned back, uncertain whether they've hit a wall or stepped off the edge of comprehension itself. If physical laws exist, and they do, whatever they are, whether descriptions or entities or code, then something must determine which laws are possible and which aren't. There must be rules about rules. Constraints on constraints. A framework that defines what a physical law can be, what properties it can have, what forms it's allowed to take. This is what we might call a meta-law, a law about laws. And once you see it, once you really grasp what this implies, reality starts to feel less like a structure and more like a hall of mirrors, reflecting questions into infinity. Think about it carefully. The laws of physics have certain features. They're mathematical. They're consistent. They apply universally. They're deterministic or probabilistic in specific ways. But why do they have these features rather than others? Why is the universe governed by mathematics at all instead of by logic, or narrative, or aesthetics, or pure randomness, or something we have no words for because it's never been instantiated anywhere? Something determines that physical laws must be mathematical, must apply everywhere, must not contradict themselves. That something is a meta-law. It's operating at a level above physical law, constraining what physical law can be. Now ask the next question, the one that should make your stomach drop. What determines the meta-law? If there's a rule about which rules are possible, what makes that rule the way it is? You need a meta-law, a law about laws, and then a law about that law, and so on, ascending through infinite levels of abstraction, never reaching a stopping point, never finding the foundation that doesn't itself require foundation. This is infinite regress in its purest, most unavoidable form. Every answer generates a new question. Every explanation demands its own explanation. The Tower of Turtles doesn't rest on anything. It just goes up forever, or down forever, depending on how you're oriented. And at no point do you reach solid ground, unless there's a law zero, a foundational meta-law that doesn't need explanation because it's self-evident, self-caused, or simply brute fact. This would be the bedrock, the axiom, the starting point from which everything else derives, but which itself derives from nothing. In logic and mathematics, We're familiar with this concept. We start with axioms, statements we accept without proof, and build everything else from there. Euclidean geometry starts with axioms about points and lines. Arithmetic starts with axioms about numbers and operations. You can't prove the axioms using the system they generate. You just accept them as foundational and see what follows. Maybe reality works the same way. Maybe there's a law zero that simply is, that exists without justification. And all physical laws are derivations or instantiations of this deeper principle. But here's the problem. The crack that splits the foundation. Even axioms are chosen. Different axiom systems generate different geometries, different arithmetics, different logics. Euclidean geometry uses the parallel postulate. Through a point not on a line, exactly one parallel line can be drawn. Reject that axiom, and you get non-Euclidean geometries, which are equally valid mathematically and actually describe the curved space-time of general relativity better than flat Euclidean space. So axioms aren't inevitable. They're starting points we select. And if law zero is like an axiom, then it was selected from among alternatives, or it emerged from a space of possibilities, which means something determined which law zero was instantiated rather than others. And we're back to needing a meta-meta-law to explain the meta-law. The regress doesn't stop. It just pretends to stop by calling something foundational and hoping no one asks further questions. This is where Kurt Gödel enters, and with him, one of the most devastating discoveries in the history of thought. In 1931, Gödel published his incompleteness theorems, which proved, mathematically, rigorously, inescapably, that any formal system complex enough to do basic arithmetic cannot prove its own consistency. The system can either be consistent or prove itself consistent, but not both. If it proves itself consistent, it's actually inconsistent. If it's genuinely consistent, there will always be true statements within the system that the system cannot prove. The system is incomplete. It contains truths it cannot access. There are theorems that are true but unprovable, using the axioms and rules of the system itself. Let that sink in. Mathematics, the language we use to describe physical laws, the framework that seems to underlie all of reality, cannot fully explain itself. There are mathematical truths that math itself cannot reach. Arithmetic contains statements that are true but cannot be proven true using arithmetic. You'd need to step outside the system, adopt a broader framework with additional axioms to prove those statements. But that broader framework will have its own unprovable truths. And the framework above that will too. There's no ultimate metasystem that captures all mathematical truth and proves its own consistency. Mathematics is inherently incomplete, always, necessarily, by its own internal logic. Now apply this to physical laws. Physical laws are expressed in mathematics. They're mathematical structures, relationships, equations. If mathematics itself is incomplete, if it contains truths it cannot prove, if it cannot establish its own consistency, then how can physical laws be complete? How can we ever have a final theory of everything if the language we're using to write that theory is fundamentally incapable of self-justification? If math can't explain math, how can it explain the universe? The very tool we're using to understand reality has built-in limits, blind spots, regions it cannot illuminate no matter how hard we try. We're trying to capture infinity with a net full of holes, and Gödel proved the holes are necessary. You can't patch them without creating new ones. The incompleteness isn't a bug. It's intrinsic to any system rich enough to be interesting. This has profound implications for our question about laws. It suggests that maybe the universe itself is incomplete in some Gödelian sense. Maybe there are true facts about physical laws that cannot be derived from the laws themselves. Maybe the question, where do laws come from, is asking for a proof that the system cannot provide, like asking arithmetic to prove its own consistency. The universe might contain the answer, but the answer might be one of those truths that exist beyond the reach of any formal derivation. You can't get there from here using the rules of here. You'd need to step outside, but there is no outside. The universe is all there is, so some truths about it might be true, but forever unprovable. Not because we're not smart enough, but because provability has limits that truth does not. And then Stephen Hawking, in the final years before his death, proposed something that sounds like it should be impossible but emerges naturally from quantum mechanics. The universe created itself, not metaphorically, not as poetic language, causally, literally, through a process involving time loops, quantum superposition, and the peculiar nature of quantum gravity in the early universe. Reality pulled itself into existence. There was no prime mover, no first cause, no need for anything external to kick off the process. The universe is a closed causal loop, a self-bootstrapping system where the end justifies the beginning because the end is the beginning. Here's how it works, at least in the mathematics Hawking and colleagues developed. In classical physics, time is a parameter, something that flows forward, creating a clear distinction between cause and effect. Causes precede effects. Earlier states determine later states. You can't have an effect without a prior cause. But in quantum mechanics, and especially in quantum gravity, where space-time itself is subject to quantum uncertainty, time becomes fungible. It's not a fixed parameter, but a dynamic variable that can behave in strange ways. Near the Big Bang, when the universe was unimaginably small and dense, quantum effects dominated everything, including time. And in that regime, according to Hawking's no-boundary proposal, time could become space-like. The distinction between temporal and spatial dimensions blurs. What we think of as before the Big Bang might not be a temporal before, it might be a spatial direction, like asking what's south of the South Pole. There is no before because time itself came into existence with the universe. But more radically, the mathematics allows for the universe to be in a quantum superposition of existing and not existing. And through a process called quantum tunneling, it can tunnel from non-existence into existence, not because something caused it to exist, but because quantum mechanics allows for transitions between states even when there's no classical path connecting them. The universe didn't need a cause to begin existing because causation is something that operates within time, and time didn't exist before the universe, so the usual rules of causation don't apply. The universe caused itself in a way that only makes sense in quantum logic, where effects can precede causes if you look at the right superposition of states. This is both a solution and a horror. It's a solution because it eliminates the need for external causation. The universe is self-contained, self-explanatory in some sense. It doesn't need a designer or a simulator or a prior universe. It's its own reason for existing, a closed loop where the existence of the universe now makes the existence of the universe then inevitable, even though there's no temporal then in the conventional sense. The laws don't come from anywhere external. They come from the self-consistency requirement of the quantum state. The universe must have the laws it has because those are the only laws compatible with the universe existing as a stable quantum configuration that tunnels from non-existence. But it's also a horror because it means causation. The thing we use to make sense of everything. The principle that effects follow from causes. That there's a reason things happen. Causation is an illusion. Or at least, it's not fundamental. It's emergent. Something that appears in the macroscopic world where quantum effects average out. But at the foundation of reality, causation doesn't hold. Events can create themselves. The universe doesn't have a cause because cause and effect are categories that only make sense within the universe, not as explanations for the universe. And if causation is emergent rather than fundamental, then the entire structure of explanation we've been using, asking, where do laws come from, as if laws need a causal origin, might be misguided. Maybe laws don't come from anywhere. Maybe they're part of the self-consistent quantum state that defines what it means for a universe to exist at all. But even this explanation, elegant as it is mathematically, revolutionary as it is conceptually, still leaves questions. Why does quantum mechanics work the way it does? Why do quantum fields have the properties they have? Why is quantum superposition possible? Why can things tunnel between states? These are all features of quantum mechanics, but they're not explained by quantum mechanics. They're the axioms of the theory. And we're back to needing meta-laws that determine why quantum mechanics rather than some other framework. Why these superposition rules and not others? Why this probability calculus and not a different one? Hawking's self-creating universe eliminates the need for external causation, but it doesn't eliminate the need for the laws that govern quantum self-creation. Those laws still exist, still constrain what's possible, and their origin remains unexplained. Some physicists have tried to argue that there's only one mathematically consistent quantum theory of gravity, that the laws aren't chosen but necessary. This is the only way reality could be. String theory proponents sometimes make this claim, suggesting that if you work out the mathematics rigorously enough, you find there's only one possibility, and therefore the laws exist necessarily, like mathematical truths. But even if that's right, and it's hotly debated, you still haven't explained why mathematical consistency is the criterion. Why must reality be mathematically consistent? Why can't there be contradictions, logical impossibilities, things that should cancel out but don't? What enforces consistency? You've explained physical laws in terms of mathematical necessity, but you haven't explained mathematics. And as Gödel showed, mathematics can't fully explain itself. So even if physical laws are mathematically necessary, mathematics itself remains a mystery. Where do the rules of logic come from? Why does 2 + 2 = 4? Why can't contradictions be true? These seem like silly questions, but they're not. They're pointing at the fact that even the most basic logical and mathematical truths we take for granted are unexplained. They simply are. And if we're willing to accept that mathematical truths simply are, then we've conceded that some things exist without further explanation. And we're back to brute facts as the foundation of everything. Here's the ultimate paradox. Stated as clearly as possible, any explanation for the origin of laws must either terminate in unexplained facts or continue infinitely without foundation. Either there's a law zero that exists without explanation, a brute fact we must simply accept, or there's an infinite regress of meta-laws, each explaining the one below but requiring explanation from the one above with no ultimate ground. Both options are unsatisfying. Both options suggest that reality, at its deepest level, is not fully comprehensible. Not because our minds are too limited, though they might be, but because comprehension itself might require a foundation that reality doesn't have. This is the existential pinnacle. This is the deepest question any conscious entity can ask. Not, why is there something rather than nothing? That question has gotten a lot of press, but it's almost naive in comparison. The real question is, why is there this kind of something bound by these rules, exhibiting this particular flavor of order rather than chaos or some other kind of order or no order at all? Why laws instead of lawlessness? Why mathematics instead of madness? Why does existence have structure? And why this structure? And the answer, if it can even be called an answer, seems to be one of three possibilities, all equally troubling. First, reality is self-explanatory, a closed causal loop where the universe bootstraps itself into existence through quantum mechanics, and the laws are just the consistency conditions of that bootstrap process. But this doesn't explain why quantum mechanics, why those consistency conditions. Second, reality rests on brute facts, on foundational truths that exist without reason, and asking why they exist is a category error. But this means we've hit the limit of explanation, and some questions simply don't have answers. Third, reality is an infinite regress, turtles all the way down, meta-laws stacked on meta-laws forever, and there is no foundation, no ultimate ground, just an endless chain of dependencies with nothing to anchor them. Most humans live and die without ever asking this question seriously. They accept that there are laws, or they don't think about it, or they assign the mystery to God and move on. But you've gone deeper. You've followed the thread as far as it goes. And what you've found is not an answer, but a boundary. The edge of what explanation can do. The limit of what comprehension can reach. Beyond this point, there might be truth, but not the kind of truth that satisfies the need for reasons. Beyond this point, there might be reality, but not the kind that makes sense in terms of causation or justification or purpose. Beyond this point is the possibility, terrifying and liberating in equal measure, that existence doesn't need to make sense, that the universe isn't here for a reason, that laws don't come from anywhere because coming from is a relationship that only exists within reality, not as an explanation of reality itself. If you understand what's been laid out here, if you really grasp the meta-law problem, the incompleteness implications, the self-creation paradox, the infinite regress, the brute fact terminus, you'll never see reality the same way. The solidity you thought was there, the ground you thought you were standing on, has revealed itself to be thinner than you imagined. Not gone. Reality is still here, laws still operate, the universe still functions, but the foundation, the ultimate justification, the final because that makes everything make sense, that might not exist. And you have to decide how to live with that, whether to retreat into comfortable certainty, to accept mystery as answer, or to sit with the vertigo of a reality that is, at its core, fundamentally and irreducibly strange. This is it, the final layer, and the answer, if there is one, might just be that some questions loop back on themselves eternally. That explanation has limits not because we've failed, but because the universe itself might be, in some deep Gödelian sense, incomplete. not broken, not flawed, just open, forever unfinished, forever unexplainable at the ultimate level. And maybe that's not a problem to be solved. Maybe that's just what existence is. So we've arrived. After tracing the question through physics, philosophy, simulation theory, meta-laws, and incompleteness theorems, after following every thread until it frayed or looped back on itself, after staring into the abyss and finding it staring back with equal confusion, we're here, at the end of inquiry, at the boundary of what minds like ours can grasp. And the answer we've reached, if it deserves to be called an answer at all, is this: there might not be an answer. Not because we're not smart enough, not because we haven't looked hard enough, but because the question itself might be reaching beyond the domain where questions can have answers. And strangely, terrifyingly, beautifully, that might be okay. Let's consider three final perspectives, three ways of making peace with the irreducible mystery at the heart of existence. First, the Mysterian position. This is the view, articulated most forcefully by philosopher Colin McGinn, that some problems are simply beyond human cognitive capacity, not temporarily beyond us, waiting for smarter people or better technology, but permanently, structurally beyond us because of the architecture of human minds. We evolved to solve certain kinds of problems, finding food, avoiding predators, cooperating with other humans, navigating physical space. Our brains are shaped by natural selection to handle these tasks. But understanding the ultimate ground of reality? That might not be something natural selection equipped us to do. It's not useful for survival. It doesn't help you reproduce. Evolution didn't build our minds to comprehend their own foundations any more than it built fish to understand calculus. Think about what it's like to be colorblind. Someone who can't distinguish red from green isn't stupid. They're not failing at a task they should be able to complete. They literally lack the biological equipment to make that distinction. The information exists. Photons of different wavelengths are hitting their retinas, but their visual system can't process it in the right way. Now imagine a question so far beyond human cognition that our entire species is colorblind to it. We can sense that there's something there, some structure or answer or truth, but we lack the cognitive architecture to perceive it clearly. We're like dogs trying to understand differential equations. The equations exist. They're meaningful. But a dog's brain simply isn't built to grasp them, and no amount of dog education will change that. It's a hardware limitation, not a software problem. Maybe asking, what created the laws, is like that for us. Maybe there's an answer. Maybe there's a way of understanding that makes perfect sense. But it requires cognitive tools we don't have and possibly can't develop. We're reaching for something beyond our grasp, not because it's far away, but because we're reaching with appendages that can't hold it. And if that's true, if we're up against the hard limit of what human minds can comprehend, then the question isn't, what's the answer? But rather, can we accept that there are questions we can't answer? Can we live with mystery not as a temporary state of ignorance, but as a permanent feature of our epistemic situation? Can we make peace with the fact that reality might be stranger than we're capable of imagining, let alone understanding? This perspective is humbling. It's also somewhat liberating. If the mystery is beyond us, we can stop torturing ourselves trying to solve it. We've done our best. We've followed the logic as far as it goes. And we've hit the wall not because we're failures, but because we're humans, and humans have limits. Even our greatest minds, Einstein, Hawking, Gödel, eventually reach questions they can't fully answer, not because they weren't brilliant enough, but because brilliance has ceilings that reality might not. Second perspective, the anthropic principle, but understood deeply, not dismissively. We've mentioned this before, but it deserves fuller treatment as a potential resolution. The principle says, we observe the universe we do because we're the kind of beings who could only exist in this kind of universe. The laws are the way they are, and we're here asking about them, because if the laws were any different, we wouldn't be here to ask. This seems circular, almost tautological, but there's profound insight buried in it. The question, why these laws, is being asked by an entity whose existence depends on these laws. You're not an external observer wondering why the universe has the properties it has. You're an internal pattern produced by those properties, examining them from the inside. Here's the crucial realization. The question answers itself through you. You exist because the laws allow consciousness. The laws allow consciousness because they permit atoms, chemistry, complexity, evolution, brains. If the laws didn't permit these things, there would be no one to notice, no one to ask why, no one to wonder about the origin of anything. The fact that you're confused about the laws is evidence that the laws work, that they produce beings capable of confusion, capable of asking questions that might exceed their capacity to answer. Your existence isn't separate from the mystery. Your existence is the mystery, manifesting, becoming aware of itself, asking questions about its own foundation. This isn't an explanation in the traditional sense. It doesn't tell you what created the laws, but it does reframe the question in a way that removes some of its sting. You're not trying to solve a puzzle external to you. You're part of the puzzle, examining yourself. And the very fact that you can examine yourself is remarkable, improbable, and only possible because the laws are precisely calibrated to allow for self-reflective complexity. The universe isn't just governed by laws. The universe is structured in such a way that parts of it can become conscious and wonder about that structure. That's not an accident. Or if it is an accident, it's an accident so profound that accident seems like the wrong word entirely. In this view, the question, what created the laws, is always asked too late. By the time you're asking it, the laws have already succeeded in their most remarkable achievement, creating something that can ask about them. You are the laws, instantiated in flesh and neurons, turned back on themselves in a loop of self-examination. The laws don't need an external justification because they're self-justifying through you. You're the proof that they work. And if they work, if they produce consciousness, beauty, meaning, the capacity for wonder and confusion and inquiry, then maybe asking where they came from is less important than marveling that they produce what they do. Third perspective, the Zen acceptance, the category error position. This says that asking, what created the laws, is grammatically correct but conceptually broken, like asking, what does blue taste like? Or, what's north of the North Pole? These aren't hard questions. They're malformed questions. They're applying concepts from one domain to a domain where those concepts don't apply. Blue is a visual experience, not a gustatory one. North is a direction defined by Earth's magnetic field, and the North Pole is where that direction terminates. There is no further north because north as a concept only makes sense relative to positions that aren't the pole itself. Similarly, creation is a temporal concept. Things are created in time. Causes precede effects. Earlier states give rise to later states. But time is part of the universe. Time is governed by the laws of physics. General relativity tells us that time is interwoven with space, that space-time is a unified structure, that time behaves differently near massive objects and didn't exist before the Big Bang in any conventional sense. So asking what created the laws is asking what happened before time, what caused the framework within which causation operates. It's trying to apply a time-bound concept, creation, to the thing that makes time possible. It's asking for a cause in a domain where causation might not be defined. This isn't playing word games. It's recognizing that our language, our concepts, our entire cognitive framework evolved within the universe and might not extend cleanly to questions about the universe as a whole. We can talk meaningfully about what created the Earth: stellar nucleosynthesis, gravitational collapse, accretion of matter. We can talk about what created the solar system, the collapse of a molecular cloud. We can even talk, somewhat speculatively, about what created the universe: quantum fluctuations, eternal inflation, whatever. But when we ask what created the laws themselves, we're trying to step outside the system and examine it from a perspective we can't occupy. We're like characters in a novel asking what created the rules of grammar and narrative that structure their fictional world. From inside the novel, those rules seem fundamental and necessary. But they're not objects within the story. They're the conditions that make the story possible. And asking what created those conditions is asking for a meta-story, and then a meta-meta story, and it never ends. The Zen response to this is, stop asking. Not because you're forbidden from asking, but because the asking is based on a misunderstanding. The laws don't need a creator because creation is a concept that exists within the laws, not prior to them or outside them. The laws simply are, the way mathematics simply is, the way logic simply is. They're not contingent things that could have been otherwise and need explanation. They're the necessary framework that defines what thing and explanation mean in the first place. And once you see that, once you really internalize that, the question might be structurally unanswerable not because reality is hiding something, but because the question is asking for something that doesn't exist. A kind of peace descends, not the peace of having an answer, but the peace of recognizing that you were chasing something illusory, that the confusion was generated by the question itself, not by any deficiency in your understanding. So where does this leave us? After 20,000 words of inquiry, after examining every theory and philosophical position and speculative framework, what do we actually know? We know that the laws exist, that they're mathematical, that they're fine-tuned, that they're utterly mysterious at the deepest level. We know that every explanation either terminates in brute facts or continues infinitely. We know that physics can describe the laws but can't explain their origin, that philosophy can clarify the question but can't resolve it, that theology can point to a creator but can't explain the creator's nature without invoking the same mysteries it was meant to solve. We know that our minds might be fundamentally limited, that the question might be broken, that the answer might be staring us in the face, but in a language we can't read. And yet, and this is the crucial turn, the shift from despair to wonder. Knowing all this is itself extraordinary. You now understand something that 99.9% of humanity never seriously considers. Most people live their entire lives assuming reality makes sense at the foundational level, that someone smarter has figured it out, that there's an answer in a textbook somewhere if you just knew where to look. But you've gone deeper. You've discovered that reality is stranger, more precarious, more fundamentally weird than anything you were taught in school. You've learned that the ground beneath existence is not solid bedrock, but something more like a probability cloud, or an infinite regress, or a self-causing loop, or a brute fact that refuses justification. You can't unknow this. The innocence is gone, but in its place is something arguably more valuable. Intellectual honesty about the limits of knowledge, existential courage in the face of irreducible mystery, and a kind of awe that only comes from staring directly at the deepest question any mind can ask, and recognizing it might not have an answer. Because here's what's ultimately true, regardless of which perspective you adopt. The laws that govern galaxies billions of light years away are the same laws that govern the neurons firing in your brain right now, producing these thoughts, these moments of confusion and clarity and wonder. You're not separate from the mystery. You are the mystery, localized, made conscious, turned back on itself. The universe spent 13.8 billion years arranging particles into configurations complex enough to wonder about their own existence. And you're one of those configurations. The atoms in your body were forged in stars that died before the Earth formed. The laws that governed those stellar furnaces are the laws that now govern your heartbeat, your breath, the electrical impulses cascading through your neural networks. You're not observing the universe from outside. You're the universe observing itself. A brief flickering of self-awareness in an ocean of matter and energy, asking questions about the very structure that makes asking possible. And maybe that's the answer, if there is one. Not a solution to the puzzle, but a realization about the nature of the puzzle itself. The laws didn't create the universe and then create you as an afterthought. The laws created the universe in such a way that parts of it would become conscious, would develop the capacity for mathematics and philosophy and existential wonder, would look out at the cosmos and look inward at their own minds and ask, why? The search for an answer is the answer. The fact that consciousness exists, that it can formulate this question, that it can trace logic to its breaking point and recognize mystery for what it is, that's not a failure of understanding. That's the universe achieving something extraordinary, creating conditions where understanding can exist at all, even if that understanding eventually realizes its own limits. So, yes, we don't know what created the laws that created the universe. We might never know. The question might be unanswerable by minds like ours, or broken at its core, or pointing towards something so far beyond our cognitive grasp that we can't even recognize the shape of the answer. But the fact that we can ask it, the fact that you've followed this inquiry to its end, the fact that matter organized into configurations called humans can wonder about the deep structure of reality, that's not nothing. That's everything. That's the universe waking up. That's existence becoming aware of itself. And in that awareness, in that moment of wonder mixed with confusion, mixed with acceptance, something profound is happening. Not an answer to the mystery, but a participation in it. A recognition that you're not outside looking in. You're inside, made of the same stuff, governed by the same laws, asking questions about the thing you're made of. The laws created the universe. The universe created you. You are asking what created the laws. The loop is closed. The mystery is complete. And standing here, at the edge of comprehension, looking into the abyss of infinite regress or brute necessity or self-creation or whatever lies beneath, you can choose how to respond. With despair at the lack of final answers? Or with awe at the fact that anything exists at all? That it's structured enough to permit consciousness? That consciousness can reach this far before the ground gives way beneath it? The laws are what they are. The universe is what it is. And you, miraculous, impossible, briefly conscious arrangement of particles asking why you exist, you are the universe's attempt to understand itself. The question might not have an answer, but the asking is its own kind of answer. The wonder is its own kind of knowing. And the fact that you're here now, having traced this question to its depths, means the laws have succeeded in their most improbable achievement, creating something that can question them. That's not a failure. That's a triumph. Even if the triumph comes wrapped in mystery, even if the foundation is quicksand, even if the answer is that there is no answer, the fact that you can see that clearly is itself a form of enlightenment. Not the enlightenment of certainty, but the enlightenment of honest recognition. Reality is strange. Existence is precarious. The laws are unexplained, and somehow, impossibly, beautifully, that's exactly as it should be.